Hi children, this is your physical science facilitator SS from Commander Group of Schools. Welcome to the online classes. In the last class, we discussed how to prepare the acids and how to identify with the help of indicators. And we follow a chart also, how the blue litmus, red litmus, methyl orange and phenolphthalein changes in acidic medium and basic medium also. Okay, and I think all of you are having your textbooks and writing notes. If not, pause the video and get the textbooks and writing notes. Okay, so yesterday I said about in the last class I said litmus paper or litmus solution can be obtained from the lichen plants. Now just open the page number 20. At the bottom there is a box. Do you know? In that few important things are there, just underline them. First thing is about litmus solution from lichen. So litmus solution, lichen, underline that. In that second line, one more thing is the thallophyta. So which belongs to the thallophyta. And just beside that, one more important point is that neutral solutions are purple in the color. That's very important bit. Purple. Which one? Neutral solutions. Yes. Besides that, few more are given to identify different colors. Okay, now let us come today's session about in the last session we should know that how to prepare the acids. Now today class we are going to know how to prepare the bases and how we can test them. And let us see how we prepare the acids. When the non-metallic oxides dissolves in water. When the non-metallic oxide dissolves in water, they produce acids. Now, let us see how we can produce the bases. That's about when metallic oxides when they dissolve in water. When they dissolve in water. Then what happened? They will produce bases. So previously how we produce the acids? Non-metallic oxide dissolves in water, they produce acids. Now metallic oxides, when the metallic oxide dissolves in water, they produce bases. Right. You know about the metals? So we have some metals. Yes. Sodium is a metal. Good. Magnesium is a metal. Calcium is a metal. Of course, zinc. Iron, and of course, all these are metals. But what is the requirement? Metallic oxides. So, we have to go for the oxides. Sodium oxide. For this sodium, we are having sodium oxide. What is that sodium oxide? Na2O. For magnesium oxide, MgO. Calcium, CaO. Similarly, of course, iron is two oxides, Fe2O3 and Fe3O4. Let us come to this one. See here, Na2O, MgO, CaO. So like this, about based on this oxidation number we are writing. Children, use these variations for the bases. Without oxidation number, ions, valency, it's very difficult when you are going for higher grades. So use these variations to enrich your knowledge, especially the basics. About oxidation numbers, basics, oxidation numbers, ions, valencies. Right. Then it is very easy. Why it is coming Na2O? Why it is not coming for magnesium? All these things. By the criss-cross method, you can easily identify if you know the oxidation number. So these basics are very crucial. These are just like H-dot. Wherever you go, they will follow. So don't forget about the oxidation numbers, ions, valence and valences. Use this vacation properly. I think in SOS also, in SAS, I given each and every oxidation number, valences and all those things. Once go through that. Now, when they dissolve in water, okay, sodium oxide dissolves in water and they will produce base. It's about the base. Two sodiums are there, two hydrogens are there, just keep two here. So, NaOH. Whenever OH is there along with the metal, we consider as the hydroxide. Sodium hydroxide. Don't forget OH along with the carbon, that is alcohol in the functional group. Okay, when we are discussing about the 12th chapter, suddenly I asked. OH is there with metal. Sodium is a metal. OH. Sodium hydroxide. Sodium hydroxide. So sodium hydroxide is the chemical name. Sodium hydroxide is the chemical name, but there is a common name for it. That's what we call caustic soda. Caustic soda. I think it is very clear to you. Sodium oxide, metallic oxide, dissolves in water. It ready to produce base, sodium hydroxide. Whenever OH is there along with a metal, we have to be considered as hydroxide. Sodium hydroxide is the chemical name. What is the common name? Caustic soda, right? Then when you see about this magnesium oxide, it's also going to dissolve in it water, and magnesium hydroxide. Magnesium hydroxide. OH is there, but balance of the magnesium is 2, so 2 OH ions have to be considered. Magnesium hydroxide. So what is the chemical name? Magnesium hydroxide. Magnesium hydroxide. It's about chemical name, but there is a common name for this. That what we call milk of magnesia. Milk of magnesia. Okay. So this milk of magnesia, of course, it is very clear, just like the milk, so that we call it as the milk of magnesia. Magnesium hydroxide. It's very important for us because it is the main pigment in antacid tablets. Anti-acid. When you are suffering from acidity, they suggest some tablets. In that main ingredient about magnesium hydroxide, nothing but milk of magnesia. Okay, further gas also we will discuss that. So metallic oxide dissolves. Similarly, calcium, of course, calcium oxide. When it dissolves in water, it will produce calcium hydroxide. Calcium hydroxide. Very easy to remember. OH is there, hydroxide. Metal is there, metallic hydroxide. Sodium is the metal, sodium hydroxide. Magnesium, magnesium hydroxide. Calcium, calcium hydroxide. So there is a common name for this calcium hydroxide. That's about the slaked lime. Slaked lime. Okay. Don't forget about the common names. Mostly in the half mark they are going to be asked on discussion. Student A, student B, statement 1, statement 2. In such questions they will ask about different criteria for questions. So, calcium hydroxide. Now it is clear to you how we can produce the bases. Okay, how we produce the acids? When non-metallic oxide dissolves in water, we will get acids. Now when the metallic oxide dissolves in water, they produce bases. So here you should remember one thing. These are metallic oxides. Metallic oxides are also basic in nature. Half mark question. All the metallic oxides, mostly they will give this one. CaO is dash in nature. Or student A said CaO is basic in nature. Student B said CaO is acidic in nature. Whom do you support? That is the question given. So whom do you support? Immediately is there metallic oxide now. Metallic oxides are ready to produce bases. So it is basic in nature. For example, I ask carbon dioxide. Yesterday we did one thing. When you open that soda bottle, immediately carbon dioxide gas has evolved. So carbon dioxide, carbon is a non-metal and oxide. Non-metallic oxides are ready to produce acids. So non-metallic oxides mostly are acidic in nature. Metallic oxides mostly basic in nature. Okay, I think it's clear for you. Now let us see how we prepare bases. For that one, I am going to prepare magnesium hydroxide. Let us see how we can prepare it. I think you understood? Yes. Let us go for that activity. How we produce the bases. For that production of bases, what are the requirements? Yes, we need one metal. Yes, for that I am going to get the metal. So it's about the metal. Magnesium. Magnesium ribbon. We call it magnesium ribbon. It's about a metal. Okay. So metal. If only metal is sufficient for us. No. What we need? Metallic oxide we need. So metallic oxide. What is the metal I am going to take here? Magnesium is the metal. But what is the requirement? Magnesium oxide. Then how will you get the magnesium oxide? When this magnesium burn in the presence of oxygen. When magnesium burn in the presence of oxygen, it will use magnesium oxide. Of course, if purely oxygen is not available, so I am burning this magnesium in the presence of air. I am burning the magnesium in the presence of air. So when I am burning this magnesium in the presence of air, besides the magnesium oxide, magnesium nitrate also form. So slightly the salts. Okay, no problem. The experiment will be nice. Right. So it's about magnesium ribbon. Now we have to burn this magnesium ribbon in the presence of air. Okay. So let us see about that. How we will get this one. Okay. We will see that. So okay, children, here we are ready to do that activity. How to produce the bases. Requirement, one metal, yes, metal, but directly we can't touch when it's going to burn. For that, I am going to take one holder. Had to burn this one because what is our requirement? Not metal, metallic oxide. So from this magnesium to we want to get magnesium oxide. How we will get? When this magnesium burn in the presence of oxygen, it will use magnesium oxide. It will use magnesium oxide. So first we have to burn this magnesium in the presence of oxygen. Purely oxygen is not available, so we are burning this magnesium in the presence of air. So besides this magnesium oxide, magnesium nitrate will also form, but nothing to worry. The magnesium oxide will dissolve in water. We will go for that. Now, magnesium ribbon. This is the magnesium ribbon. And spirit lamp, what? Spatula. Okay, so to prepare the magnesium oxide, these are the requirements. Okay, it is a moderate reaction. It will take some time to burn the magnesium. It will take some time to burn the magnesium in the presence of air. And we will use magnesium oxide. Yes, let us see. So when you are going to burn, you should keep on the top layer. In 8th class you will learn the top layer, it has maximize, it's going to burn. Dazzling light will come. Very bright light will come when it's burn the presence of oxygen. That about magnesium oxide is going to be formed. I am going to collect it in the spatula. Yes. I am collecting that magnesium oxide. So, here so many questions that are going to be imposed. That when magnesium is going to burn in the presence of oxygen, so it is adding of oxygen, no? Adding of oxygen is called oxidation reaction. So, magnesium oxide, formation of magnesium oxide is an oxidation reaction. Besides this, you may know one more thing. Magnesium is a metal and oxygen is an element. So when the two different elements are going to combine, it's giving magnesium oxide. That's what we call combination reaction also. Magnesium, oxygen combined gives the magnesium oxide, is a combination reaction also. So many questions are involved here. When magnesium burn in the presence of oxygen, what we call that reaction? Oxidation reaction or combination reaction. Right. What is our aim? To produce base. What we got now? Magnesium oxide. Now when this magnesium oxide dissolves in water, I am going to collect this magnesium oxide. I am collecting this magnesium oxide into a boiling tube. Carefully you have to be collected because it's very porous. I am collecting this magnesium. Yes, it's about magnesium oxide. I collected this magnesium oxide in a boiling tube. So metallic oxide is ready. What is next one? Water. When this metallic oxide dissolves in water. Metallic oxide is ready to dissolve in water. Yes, it's going to be dissolved in water. Yes, it's dissolved in water. Magnesium oxide. Already I told you that this reaction is not going to be done in the presence of oxygen, in the presence of air. So besides this magnesium oxide, magnesium nitrate is also formed at the bottom. But if our activity is perfect or correct, then it's a base, no? What is the color of basic solution in the presence of methyl, orange or phenolphthalein? I am going to take phenolphthalein here. So yesterday one table, one chart also I show you about phenolphthalein. I am going to add to who? Base. What is the color, children? Very good. Pink is the correct. So if what we did is the correct, if it turns into pink, then our experiment is correct. Otherwise, don't suspect. Yeah, I am going to add this one to this. Yes, children, you may see that it's going to turn into pink. Have you seen that? Yes. Why not exactly? Because besides magnesium oxide, what is there? Magnesium nitrate is also there. So that besides the pink, you are getting some solution is also there. Okay, you may see that. So pink color is there at the bottom. So magnesium oxide going to turn into. Okay. So this is the method to prepare a base. I think you may understood how to prepare the bases. Okay. Right. Now we'll go other topic. Right, children. Magnesium oxide, when it dissolves in water, it will give magnesium hydroxide. What is the common name of magnesium hydroxide? Yes, milk of magnesia. Right? Have you understood how to prepare this one? Now, before that activity, I kept some tamarind there. Have you observed? What is the acid present in the tamarind? Yes, tartaric acid. Remember, tartaric acid. Again, by the next class, or maybe by the next class, I am going to ask what is the acid present in the tamarind. Right. So this is the method to prepare what? Bases. So when the metallic oxide dissolves in water, they are ready to produce bases. Now, let us see one chart. Now, if you open that page number 21. Okay, so that page number 21, one table is there. Have to go for the table, and everyone be ready with the pencil or pen, anything to complete the table. Okay. Okay, children. Are you seeing the page number 21 of your textbooks? There, one table is there like this. How we have to change this sample solution and red litmus, blue litmus, phenolphthalein and methyl are our solutions. Let us see. HCl. How the red litmus will change in HCl? First, we have to know what is the nature of these substances. HCl, acid, hydrochloric acid, sulfuric acid, nitric acid, acetic acid. Acetic acid is the chemical name. Common name is vinegar. 5 to 8% of acetic acid is called vinegar. Remember that, vinegar. Right. Now, litmus paper. What is the red litmus? It is about acidic solution. What is the color? Unchanged. Unchanged. What about the blue litmus? Acidic medium. Acid will convert the blue litmus into red. It turns into red. Phenolphthalein. It is an acid. Phenolphthalein is about colorless. Colorless. Methyl orange, red. It is also acid. You should write. I am giving details. You have to write. Okay, it is also acid. Unchanged, red, colorless, and of course red. Nitric acid, same. It is also acid. Are you following now? Not. Don't forget, note tables should be empty in the textbook. Acetic acid, 5 to 8% of acetic acid is vinegar. Have you seen the vinegar? Most of gobi manchurian etc. They are going to add some colorless solution. No? That's vinegar, 5 to 8% of the. Now it is also acid. So like this. And sometimes highly diluted acetic acid may not change the blue litmus into red. Highly diluted because less percent of H plus ions will be there in the higher classes and coming classes will not about it. These are about acids. Now NaOH, sodium is a metal hydroxide. Metal hydroxide, is it? Yes, correct. Now base, red litmus. What happened? The color of red litmus paper in the basic medium. In the basic medium, red turns into is blue. What about this one? Unchanged. Phenolphthalein. It's very nice to see. Pink in color. Methyl orange. Yellow in color. Okay. So similarly, potassium hydroxide. Sodium. Potassium. These are very strong metals. Okay, so immediately the base is also strong. Sodium hydroxide is a very strong base. Potassium hydroxide is also strong base. So what happened? It will changes into blue. I am giving details, but you should write. Magnesium hydroxide. What is the other name of magnesium hydroxide? Yes, milk of magnesium. Where we are using that? Antacid tablets. Ammonium hydroxide is a weak one, weak acid, it's a weak base. Right. Calcium hydroxide, slate it is also like this. So, have you completed? Have you completed the table? The page number 21 of the textbook. Okay, I am repeating. No table should be empty in the textbook. We must because and mostly the 30-second question may come like this. Informative skills, table based questions like that. Informative skill questions will come. Most probably based on the tables or the content what we are having. Okay, see, let us see once. So these are the indicators: red litmus, blue litmus, phenolphthalein, methyl orange are the indicators. And these are the sample solutions: acidic solutions, basic solutions. In the acidic solution, red litmus unchanged, blue litmus turns into red, phenolphthalein is colorless, acidic. Phenolphthalein colorless. Same phenolphthalein in basic is pink. Okay, don't get confused. Now sodium hydroxide base red litmus changes into blue, blue litmus will remain unchanged, phenolphthalein changes into pink, methyl orange is yellow. Clear? Right. Now let us go for an interesting and very important activity: how and what happen when metals are react with acids. Very, very important for 4 marks or maybe 1 mark or half marks, 2 marks. Certainly the concept will be there. We will go for that. What is that? What happens when metals react with acids? Right? Okay, children. The very important activity in this chapter is about what happens when metals react with acids. So children, first you should know the general equation. If you know the general equation, whatever the examples, you can easily insert if you know the basics. What is the question? What happens when the metals, what they are doing? They are going to react with whom? Acids. Metals are going to react with acids. Then what happened? Is salt and hydrogen gas. Hydrogen gas is evolved. It's about the general equation. If you know the general equation, then half of the content you are going to be analyzed based on the particular thing. Metals are going to react with acids. Then hydrogen gas is evolved. How should we know whether this is hydrogen gas or not? For that, test of hydrogen. What is the test of hydrogen? When a burning splinter, a candle is inserted into the hydrogen gas, it will puts off with a pop sound. And the hydrogen gas will burn with blue flame. What is the test of hydrogen? Hydrogen gas puts off the burning splinter with a pop sound. Pop sound. And the gas burn with blue flame. That is the test of hydrogen. Okay. Now, so this is the concept. The question may be asked in different manners. Maybe Jahnavi has observed that a gas is evolved by doing an activity and it puts off with a pop sound. What is the reaction? How you are going to explain? They may ask like this. For that, you should know what is the gas is evolving, what might be the chemical reactions. And one more person may be asked like this. A metal, unfortunately, dropped into an acid, then what happens? Or how can you prove that hydrogen gas is evolved when acids are reacting metals or metals reacting to acid? So if you know the content, if you know the concept, however the question is going to be and whatever the question is going to be, you can be able to answer. Now, if it comes for the 4 marks as an activity, any activity, what is the first thing? Aim. What is our aim? Aim is there in the question itself. What is the question? What happens when metals react with acids? Or what is the question? Show that hydrogen gas is evolved when the metals are reacting with acids. Based on the question, our aim will change. For example, show that hydrogen gas is evolved during the reaction of metals and acids. So what is our aim now? Hydrogen gas is evolved. Hydrogen gas is evolved. To prove that, what is the aim? To prove that, what we have to prove? Hydrogen gas is evolved when metals are react with acids. Okay. For this, what are the apparatus that what we need? Okay, so by drawing a small diagram, we can analyze what are the apparatus that what we need. For that, first we need 1 retard stand. 1 retard stand we need. 1 retard stand like this, and to this retard stand there will be a holder like this. To this holder, you have to be suspend 1 boiling tube. Boiling tube like this, one boiling tube. Okay. So in the textbook they are given directly they are given the delivery tube, but actually when we are doing in the lab, thistle funnel also needed. Okay, so directly when you are going to add metals and acids, a fast reaction. Immediately the reaction takes place. Before inserting the cap or maybe the delivery tube, the gas may be escaped. But what is there in the textbook, that what we have to draw. Okay, so that I am drawing what is there in the textbook. Now like this, one monohole rubber stopper is there. So before going to close this, we have to take some zinc granules in it, and hydrochloric acid, diluted hydrochloric acid. Okay, and now it is a monohole rubber stopper, now single hole rubber stopper, and one delivery tube. What delivery tube has inserted like this into a container and a trough like this. The trough which is having soap solution, It's about the soap solution. So it is the diagram given in the textbook, but actually it should be a 2-hole rubber stopper. Here you have to insert thistle funnel. Here thistle funnel you have to insert. Through this thistle funnel, with the help of thistle funnel, you have to insert acid, because it is a fast reaction. If you are not using the thistle funnel, how you are going to add this one? So immediately the reaction takes place. Before inserting this delivery tube, the gas may be escaped. Okay, So, but what is there in the textbook, we have to follow. Okay, so I am giving the homework as the parts. What is about it? Retard stand. And what about this? Boiling tube. These are zinc granules. Diluted HCl. Diluted HCl. It's about monohole rubber stopper, delivery tube, trough, and soap solution. Okay, have you understood? Let us see once again. Retard stand, boiling tube, delivery tube, trough, monohole rubber stopper. These are the apparatus. And what are the chemicals? Zinc granules, diluted hydrochloric acid, soap solution. These are the chemicals. And we will separate it. Apparatus, retard stand, boiling tube. Of course, if you write, you may write holder also. Holder. And single hole rubber stopper, delivery tube, trough. These are the apparatus. What are the chemicals? Zinc granules, HCl, diluted HCl, and soap solution. Okay, procedure. What is the procedure? Take some zinc granules in the boiling tube. Take some zinc granules in the boiling tube. Add hydrochloric acid. Hydrochloric acid. Then it is a fast reaction. Immediately the zinc react with HCl. And one colorless gas is evolved. Here there is no chance of escaping. So it will come to this delivery tube. You can observe in this soap solution bubbles are going to appear. That bubbles indicate some gas is going to be released. How can you say that it is a hydrogen gas? In the beginning of the activity I said that the test of hydrogen. Hydrogen gas puts on the burning splinter with a pop sound, and the gas burn with blue flame. Okay? Now, that's the thing about the procedure. What is the procedure? Take some zinc granules, the boiling tube, add some diluted hydrochloric acid. Because of the fast reaction, immediately the hydrogen gas is evolved. Means colorless gas is evolved. Okay? What is our observation? Observation. I observed that some bubbles are appear in the where? Soap solution. The soap solution, he observes some bubbles which are present. That is our observation. What is the conclusion? After, before going to write this conclusion, you have to go for the test. Okay, what is the test? The burning splinter is introduced here. A burning splinter is introduced here. Like this, it's burning splinter. It's going to be put off with a pop sound. Clear? What is the conclusion? From this above activity, I conclude that hydrogen gas is evolved when metals are react with acids. Clear? Okay? So don't forget what are the different subheadings you have to follow. A, apparatus, chemicals, procedure, observation, conclusion. If you want to write, better to go for here as a test also. Okay, if any precautions are there, you have to go for the precautions also. Here thistle funnel is not used, so precaution is not there. If you are going to use the thistle funnel, the other end of the thistle funnel should be dipped into the HCl. There is the precaution. If you are using that one. Actually, when you go to higher classes, it will be the diagram. With the thistle funnel it will be. Okay, because it is a fast reaction. Okay, so we are not having all this equipment. We will do this same activity with different apparatus. Okay, is it clear for you now? Metals react with acids, salt will form, besides this hydrogen gas is evolved. It is a general equation. For this general equation, whatever the examples you may take, any metal, zinc is a metal, hydrochloric acid is a acid. Immediately what happened? And metals to acids. Immediately what happened? Hydrogen gas. So hydrogen as left over there. When hydrogen is not there, zinc is there, chlorine is there. So zinc, chlorine. What is the valence of zinc? 2. So simply give 2 here. 2 chlorines, 2 hydrogens. So it will be the 2. Okay. So metals react with acids. Then releasing hydrogen gas. Like that you may take zinc sulfuric acid or magnesium sulfuric acid. So whatever the metals are reacting with acid, immediate hydrogen gas is evolved. That's all. Okay. Right. We will see that with a small activity. Okay. The same activity we are doing without this equipment. For that, first one conical, flask and matchbox. These are the apparatus we need. And chemicals, zinc is a metal and acid, diluted acid. One small suggestion, don't do at home. Okay children? Conical flask. In this conical flask I am going to take some zinc granules. Zinc is a metal. Okay. And I am going to add hydrochloric acid to this. It is a fast reaction. So immediately the hydrogen gas is evolved. When the burning splitter is introduced there, it will give the pops. Have understood? And the gas burn with blue flame in the interior. You may see blue flame is there. That is the test of hydrogen. Thank you. Have understood? Right. Okay, ma? So when metals react with acids, immediately hydrogen gas is evolved. What is the test of hydrogen? When a burning splitter is introduced, it will give pops off. Burning splitter will put off, but gas burn with blue flame. Okay? It's about the very important conceptual question and activity question today what we discussed. Okay. Once we will see. Today we discuss how to prepare the bases and indicators colors and how the hydrogen gas is evolved and etc. Okay. Thank you. We will see you in the next class.